In this problem, to write f of x in the given form, we rearrange the function in descending powers of x. Then factor out -9 from the first two terms. Half of coefficient of x is 2 over 9, and the expression in the bracket can be written as x plus 2 over 9 squared minus 2 over 9 squared. Expanding the bracket and solving for the constant term, we get -9 times x plus 2 over 9 squared plus 31 over 9. The value of a is 31 over 9, b is 9, and c is 2 over 9. F of x is maximum when x plus 2 over 9 is 0. At this point, the maximum value of f of x is 31 over 9. Given that f of x equals 0, we form a quadratic equation with roots 3 alpha over beta and 3 beta over alpha. Roots of f of x are alpha and beta. The sum of roots alpha plus beta is -4 over 9, and product of roots, alpha beta, is -1 over 3. To determine the quadratic equation with new roots, we calculate sum of two roots. Making the denominator common, we get 3 alpha squared plus 3 beta squared divided by alpha beta. We use the identity alpha squared plus beta squared equals alpha plus beta squared minus 2 alpha beta, substituting alpha plus beta equals -4 over 9, and alpha beta equals -1 over 3, we get 70 over 81. Thus, 3 alpha squared plus 3 beta squared is 70 over 27, which is divided by -1 over 3. Therefore, sum of roots is -70 over 9. Product of roots is 9. Coefficient of x in the quadratic equation is negative sum of roots, and the constant term is product of roots. Sum of roots is -70 over 9, and product of roots is 9. Multiplying both sides of the equation by 9, we get 9x squared plus 70x plus 81 equals 0. This is the quadratic equation with integer coefficients. The expansion of x plus y cubed is equal to x cubed plus 3x squared y plus 3xy squared plus y cubed. Factoring out 3xy from the two middle terms, we get x cubed plus y cubed plus 3xy multiplied by x plus y. G of x is a quadratic equation with two roots. Here, we need to find sum of roots and product of roots. Sum of roots is equivalent to alpha squared plus beta squared minus sum of alpha and beta. Using the values, alpha squared plus beta squared equals 70 over 81. And alpha plus beta equals -4 over 9, and solving the expression, we get 106 over 81. This value is equal to -q divided by 3, the leading coefficient. Therefore, q equals -106 over 27. Product of roots is expanded as alpha squared beta squared minus alpha cubed minus beta cubed plus alpha beta. Alpha plus beta cubed is -64 over 729, and substituting the corresponding values of alpha beta and alpha plus beta into the equation, alpha cubed plus beta cubed equals -388 over 729. We then substitute alpha squared beta squared equals 1 over 9, alpha cubed plus beta cubed equals -388 over 729, and alpha beta equals -1 over 3. Solving the expression, we get 226 over 729, which is equal to r over 3. Thus, the value of r is 226 over 243. This problem requires strong algebra skills and careful calculations.